Good day, go-getters. Just hope you are doing well, because I'm also fine, guys. Yeah, I'm doing good. So in this video, guys, I will be doing about NH, by the way. What I like about NH, guys, this topic is so easy. Any learner can totalize this topic. It needs you to practice and believe yourself. And guys, I have realized that most of the learners, they don't know the symbol and they don't know the units. So NH, guys, the symbol for NH, it's E, NH. And its unit, it's joules. We use G there, joules. If you see EP, it's a potential NH, that one. Still, we'll use joules. If you see EK, it's a kinetic NH. Still, we are using joules there. Do you see? Then EM, it's mechanical NH there, which is also in joules because it's energy, as you can see. Then, guys, another thing that you should know, it is the equation to use. So this equation, guys, it is the equation of what? Of potential NH there. A potential NH, guys, it is relative to position there. It is relative to position there. So its equation, it is mgh, meaning m, it's for mass, its unity, the mass, it's kilograms there, kilograms for mass. Then g there, this one it's g, g. So g there, it's a gravitational acceleration there, which is this one, guys. It's constant. You'll get it at the back of your formula sheet. This one, it's 9.8 meters cubic per seconds there. Cubic per seconds, yeah. I hope those units, I call them correct there. So this one, you got it at the back of your formula sheet, and that h there, it's for height, and its unit for height, it's meters there. Do you see? Yeah. So this is the unit, guys, that you should know. This NH, guys, it is relative to position there. So when you change, when object there is changing a position, potential NH there, it will be possessed there. Do you understand? Yeah. So okay, guys, here we also got EK there. That EK, guys, it's a kinetic energy there, which is also in joules. Its equation, it is half mv squared. Please, guys, when you use this equation, don't forget that squared, that 2, because most of the learners, they forgot to press that 2 on a calculator. I know you will forget it, guys. Please don't forget it. It's so important to put that 2 there. Do you see? So m, as I already told you, it's a mass, and it's grams there, its units. And v, guys, it's a velocity there, which is its units, it's meters per seconds. Do you see this thing? And this NH, guys, it is relative to motion. When I'm talking about motion, guys, I'm talking about movement. It means this NH, it's relative to movement there. Do you see? Yeah, take note about that one there. In order for this NH to be there should be a movement there. Do you understand? Yeah, there should be a movement. And also, guys, EM there, EM, which is your what? Mechanical NH there. Mechanical NH, guys, it is just the sum of a potential NH and kinetic NH there. It is the sum of them, meaning it is the total of potential NH and kinetic NH there. Do you see? Yeah. And this equation, guys, it can be expressed in this format there, whereby you know EP, it's mgh, and EK there, it's half mv squared. Do you see? And these two NH, guys, they are inversely proportional to each other. EP, it's inversely proportional to EK there, meaning that EP, guys, when EP is increasing, it means that EK is decreasing there. Do you see? And when EP, it's decreasing, it means that EK will be increasing there. Do you see? They are inversely proportional. Please take note about this format. Do you see when we represent something which is inversely proportional? This is how we represent it. Do you see? And also, guys, this equation is so important. This one, this. I will show you how to use this equation. This equation, it is what we call conservation of mechanical energy. This it is what we call conservation of mechanical energy. It means that mechanical energy at the top will be equal to the mechanical energy at the bottom. Yeah, all the time during a motion, mechanical energy, guys, should be equal. Do you understand? Should be equal. Yeah, it should be equal so that energy there can be conserved there. Conservation of mechanical energy. Yeah, it means that energy there is conserved, guys. Yeah, so you should also know this thing, guys. This thing, EP, it's directly proportional to H. It means that EP, guys, it is also relative to what? To a height there. Remember, I told you that EP is relative to what? Position. So here, EP, that position, guys, is the same as your height, by the way. Do you understand? When I increase EP, it means that actually, when I increase the height, it means that EP will increase. When I decrease the height, EP will decrease, guys. Do you see? This energy, it's depending on the height. That's why it is relative to position. Do you see? Yeah. So, EK, it is directly proportional to velocity, meaning that EK is relative to what? To velocity. When I increase the velocity, I'm increasing the what? The EK there. I'm increasing the EK, guys, there. Please take note about that. That's why I told you that EK there is relative to motion, meaning it's relative to movement. And that movement, it will be caused by what? By velocity there. Do you see this thing? Yeah. So this EK, guys, it is depending on what? On velocity there. Please take note about that. Yeah. So I think now I can just go straight to what? To question there.